This talk is to present our FAccT 2021 paper, Value Cards, an educational toolkit for teaching social impacts of machine learning through deliberation. My name is Shen. This is a collaborative work with my co-authors, Wesley, Aditi, Stephen, Xu, and Hai-Yi. In this talk, we will talk about the design of our toolkit, an early proof of concept case study in a college-level computer science class, our results, limitations, and future work. Machine learning-based decision-making systems have been deployed to address many high-stakes problems in our society, raising many social and ethical concerns. Even with the best of intentions, ML development teams, constrained by limited team diversity and lack of necessary training, often struggle to fully comprehend the complicated and nuanced social issues embedded in many contemporary AI systems. In the past few years, we saw concerns raised around unfairness treatment for African American and white populations in a recidivism prediction tool, gender biases in recruitment algorithms, racial biases in image labeling technologies, etc. The need to teach computer science students, and by extension, future CS practitioners, the social impacts of the machine learning models they're going to build has become urgent. As a result, there has been an increase in calls for CS departments to complement existing technical training with issues related with fairness, accountability, transparency, and ethics. Indeed, we have witnessed a growing number of CS departments seeking to infuse FACT topics into their curricula. However, scholars working in this space have noticed that many technical training was taught as separated, stand-alone course rather than being integrated with ethical training. In this paper, we introduce a novel, deliberation-driven educational toolkit to address this concern. The Value Card Toolkit helps CS students and practitioners better comprehend, negotiate, and reflect on diverse and often competing social values in machine learning-powered algorithmic decision-making systems. As an educational toolkit, Value Cards strives to achieve the following three learning objectives. First, as past literature has pointed out, current ethical education in ML tend to separate the technical training from the ethical training. Here, we offer an integrated toolkit to help students understand both the technical definitions and trade-offs of performance metrics and apply them in real-world context. Second, past literature also point out that there is a tendency among practitioners who are not formally trained in ML to overly prioritize accuracy over other system criteria in model building. The Value Card Toolkit is designed to tackle this challenge by educating students on the significance of considering diverse stakeholder perspectives. Third, past literature in HCI also suggests that there is a lack of communication skills among developers when facing design-related tasks, which might result in poorly designed systems that can further disadvantage already marginalized populations. Here, we strive to enable CS students to better communicate, negotiate, and synthesize the perspectives of stakeholders when algorithm decisions have consequential impacts. In this paper, we offer a proof of concept study of our approach and toolkit. Here, we focus on a recidivism prediction algorithm. Recidivism prediction is a highly staked social context when algorithms have been increasingly deployed to help judges assess the risk of recidivism. As a contentious social domain that involves diverse and sometimes competing social and political interests, this topic has also generated one of the most controversial cases so far in the field of fairness and machine learning. For the purpose of this study, we recreated a recidivism prediction tool using a dataset provided by ProPublica. We focus on two demographics here, African American, and white populations. The core of the value card toolkit is the deliberation process. Instead of viewing human values in AI systems as individual dilemma that can be calculated as aggregations of individual preferences, we foreground the importance of social values and collective decision-making via deliberation. The value card toolkit uses 3 different artifacts or cards to scaffold this deliberation process: the model cards, the persona cards, and the checklist cards. Here, I describe them one by one. The first set of artifacts in our toolkit is the model cards. The aim of the model cards is to both describe the performance metrics and to capture the trade-offs across them in a machine learning-based system. Optimizing for multiple system criteria is a tricky task. Optimizing one criterion often leads to poor performance on others. The use of the model cards is to specifically capture, scaffold, and communicate those trade-offs to the participants. In this study, we generated a family of predictive models that have a wide range of trade-offs between 4 different metrics: accuracy, false positive rate, false negative rate, and disparity. Between the 2 demographic populations, African Americans and white populations. Next, given a family of models, we selected a subset of 8 models that roughly map back to the stakeholder values identified in our persona cards, as discussed below. We also offer a table, as you can see here, for our participants to better understand the range of the differences across our 8 different machine learning models. The second set of artifacts in the value card toolkit is the persona card. The persona cards are a series of cards that characterize different potential stakeholders and their prioritized values, with each corresponding to a number of the specific model cards. They describe the background of each potential stakeholder, the stakeholder's primary considerations, and some brief discussion guidelines. We created 4 persona cards in total, following the stakeholder mapping offered in a previous literature. For example, we consider judges might want to prioritize increasing accuracy when considering the design of a recidivism prediction system. Defendants might want to prioritize decreasing false positive rate as they are worried being falsely predicted as will offend again. Community members might want to prioritize decreasing false negative rate as they are mostly concerned about the safety of the community. Fairness advocates might want to prioritize decreasing disparity as they want to minimize the differences across African American and white defendants. The third set of artifacts is the checklist cards. We derived our checklist cards from previous literature, especially those practitioner-facing AI ethic guidelines. Through iterative affinity diagramming, we formalized 3 checklists for our study. The first is understanding social values, which offers high-level points in considering social impacts of AI systems. The second is identifying stakeholders, which provides a starting point for students to think about who will be at risk of experiencing impacts. The third set is analyzing impacts, which asks students to identify the type, degree, scale, and overall direction of the impacts. Here you can see the third set of the checklist cards. Now I will pass on to my co-authors Wesley to discuss our proof of concept case study and our evaluation results.
We conducted our study remotely in the Human AI Interaction class at Carnegie Mellon University in fall 2020. Here are some demographic information for our users. We have 55 students, and we have 14 Zoom breakout rooms. In our study, students were first assigned to complete an individual quiz. Then they read the value cards and make individual model selections. After that, they are assigned to teams of 4 and have team discussion. Students in each team collaboratively write a short proposal after the deliberation. In step 4, students complete a post-survey individually, and the instructors hold a subsequent reflection session to collect feedback. In step 5, students complete a post-quiz 7 days after the initial in-class activity. To test the utility of different components of the value card, in step 2, we assign 4 different conditions to students. We have baseline with only model cards and no persona cards and no checklist cards. We have checklist only condition with model cards and checklist cards with no persona cards. We also have persona cards only and checklist and persona card. For persona card, we have 4 different personas. Defendant, community members, fairness advocate, and judge. For our data analysis, we did quantitative analysis and qualitative analysis. For our qualitative analysis, we look at the group proposal, open-ended questions in the post-survey, the transcripts of in-class reflection, and the transcripts of group discussions. We did a grounded theory and thematic analysis on all 4 different text resources. For the quantitative analysis, we mainly focus on the quiz scores and metric selections. For the metric selections, we're mainly looking at the answer for the question, for any algorithm decision-making system, what metrics below do you think are the most important ones to consider in tuning the algorithm? Before diving into our findings, we would like to highlight the limited scope of our case study. We focused on a restrictive set of model performance metrics, demographic groups, personas, and their associated priorities. Specifically, we only focus on the accuracy, false positive rate, false negative rate, and disparity for the model performance metrics. For demographic groups, we only focused on the African American and Caucasians in recidivism settings. For personas, we utilized a top-down approach to create persona cards, designating 4 different stakeholders and their competing values, missing the intersectionalities of the stakeholders. For future work, a bottom-up co-design approach is needed. For our findings, we mainly focused on how the value card could help us achieving learning objectives and the pros and cons of using different variants of the value cards. First, we found that students improved their understandings of the technical definitions and trade-offs of performance metrics in machine learning. Students were able to apply the definitions in real-world context. In traditional machine learning course, the definitions of false negative rate and false positive rate are usually presented by the instructors in a mathematical formalization without engaging students within a specific social context. In our study, the immersive deliberation procedure served as a friendly yet effective environment for students to proactively apply the technical terminologies they have learned into a real-world case study. Students help each other consolidate their understanding of technical machine learning terms and the metrics trade-off. For example, one student in room 5, checklist only condition, explained the false positive rate in the context of recidivism prediction as it's having people who are actually not going to commit another crime test positive. It's like just calling them out as guilty, even they have no plan to commit any crime. After the entire deliberation, one student in room 2, baseline condition, comments that I wish we did this part of the exercise before the quiz because now I understand everything way better. As a matter of fact, from our quantitative analysis, comparing the pre-quiz average score and the post-quiz average score, we see a statistically significant difference in the average grade for the quiz score. Second, students understood the importance of considering diverse stakeholders' perspectives in the development and deployment of machine learning systems. We noticed a large population of our students endorsing the model with the highest overall accuracy at the beginning of the deliberation. However, after the group discussion, they started to recognize the overall accuracy fails to capture the nuance of social consequences the machine learning systems might have. For example, one student commented in the post survey, "The activity made me consider my previous perspectives that models can be ranked on an absolute basis by their accuracy. Although accuracy is a great metric, it is extremely general and fails to capture the nuances of societal cost of using a model with high accuracy at all costs." Third, students were able to communicate, negotiate, and synthesize the perspectives of diverse stakeholders. For example, students were able to assertively advocate for stakeholders' interest. In room 8, students said, "I'm concerned about the safety of my neighborhood. The false negative rates for those cars you mentioned are really high. It seems like we will disagree with each other." When facing conflicts, students actively negotiate and compromise in order to reach a common ground. In room 14, which is the checklist and persona condition, one student mentioned, "The models are extreme in one way or another. It either has super high accuracy or very low disparity. To satisfy everyone, we need to reach some common ground." During negotiation, students in general showed respect to others' perspectives and values. For example, in room 3, students made the following comments after another student expressed concern about model's high false positive rate. "We should all consider others' perspectives." Then after listening to what he has talked about, I think it's bad for us to have like a 50% of false positive rate. We also noticed that different combinations of the toolkits has different pros and cons. Persona cards in general help some students quickly gain empathy towards the stakeholders and articulate their values. For example, one student said, "As defendant, I am really worried about being falsely predicted as high risk, like a repeat offender. I don't want my life being destroyed just for that reason." Another student mentioned, "Besides my persona, I think we also need to look at the societal cost. I think it's really dependent on the types of crime that you're diagnosing." Persona cards also has its limitations. So students mentioned they can't really put themselves into their persona's position. The persona cards are missing some value, and persona cards made them very defensive. They're fighting for their own persona. They're not consider other personas' perspective as much as they would like to. The checklist cards in general help generating productive discussion around diverse societal value in the development and deployment of machine learning system. We noticed that in the proposal and discussion, students follow the pattern of checklist card when we offer them checklist card. However, when the checklist card and personal cards were presented simultaneously to the students, for example, in the condition of checklist and personal card, students' discussions were driven by the personas more than the checklist. Specifically, discussions in room 11, 13, and 14 did not refer to the checklist card at all, and room 12 had only one student mention the checklist only once throughout the entire deliberation. We include more quotes and more analysis in our paper around the pros and cons of the different components of value cards, and also how our value cards could help us achieving our learning objectives. Feel free to check our paper. For our future work, we would like to explore the utility of value cards in other educational settings. For example, in large cross-institutional study, with more diverse student sample or professional workshops. We would like to explore the design and use case of value cards in context other than recidivism prediction. Also, we also like to test the use of physical cards in real-world interactions instead of Zoom conference room. All the materials of value card and our study design are available on the link below. And thank you for listening.